So we've been talking a lot about measuring things. We've been measuring lengths, we've been measuring areas, measuring volumes. There are other things we could measure, including mass and temperature. So let's take a look at those. They're not as studied as often, but they're obviously very important. Mass and weight are very much related to each other. Sometimes when we say one, we mean the other. So the mass is how much quantity there is. The weight is actually a force that's exerted by gravity. So oftentimes when we say we're going to weight or to find the weight of something, we really mean its mass, although oftentimes the words are used interchangeably. In the English system, the pound is sort of the fundamental unit of mass, and then you have ounces, you have tons. In the metric system, the gram is what we call the fundamental unit of mass, and everything else as measured is based on the gram. So in terms of metric world, you've got grams, you've got kilograms, right? A kilogram is 1,000 grams. A ton is 1,000 kilograms. Now notice that this is a metric ton. A metric ton is 1,000 kilograms. That's how we're going to measure that thing. The American ton is 2,000 pounds is a ton. But in a metric ton, you've got 1,000 kilograms. Then there are smaller measures too, right? We don't usually worry about decigrams. But milligrams, if you're going to measure out medication, don't you usually measure out medication or if you're taking vitamins or something like that in milligrams, right? It's a very small weight, thousandth of a gram. So if you want to convert from grams to kilograms, you're going from grams to a much bigger unit. Well, there's 1,000 grams in a kilogram. So you're going to take those 34 grams and you're going to move that decimal point 1, 2, 3 places to the left, you'll have 0.034 kilograms, very small measure. All right, what if you're working the other direction? What if you were going from kilograms to tons? Now remember, in a metric ton, there's 1,000 kilograms. And so you would take this and you would divide it by 1,000. Right? Move that decimal point 1, 2, 3 places to the left, and you'll get 6.836 metric tons is the equivalent of 6,800 kilograms. All right, so this is kind of an interesting matching game. Do you have any idea what these things weigh in the metric system? So we've got choices down the bottom that match up with all these things up here. 2 milligrams, 2 kilograms, 100 grams, 1,300 kilograms, 9 kilograms, and 5 grams. What do you think these things weigh? A nickel, a small car, 2-liter bottle of soda, how much vitamin B6 you should get, a size D battery, and a large watermelon. Okay. Do you want to think about this for a second, pause, and come back? You can try that. Go ahead. All right, so what'd you come up with? Maybe I'm going to start with the biggest thing first. So out of all those measures, the 1,300 kilograms looks the biggest, and that car looks the biggest of all of them. So I'm going to match up my car as 1,300 kilograms. It doesn't mean every car is 1,300 kilograms. It means that out of those possibilities, that's the one that seems to work. All right, what do you think is the smallest of all of them? I'm hoping that vitamin B6 is the smallest. Otherwise, I'm going to need a lot of vitamin B6. So I'll match up the 2 milligrams with the vitamin B6. All right, what else do you think works? What are the next biggest measures, the 9 kilograms and the 2 kilograms? So out of all of these things, that big watermelon is probably the heaviest of all of them. So I'm going to match this up with the 9 kilograms. Okay, so let's match that up with the 9 kilograms. And then what do you think is next in size? Probably that bottle of soda. So let's match this up with the 2 kilograms. All right, then let's go back to the other version. What are the small measures that you have? So we've got 100 grams and 5 grams. So we should have 2 things left where one is heavier than the other. So out of the nickel and the battery, I'm going with the battery being heavier. So let's call the battery the 100 grams, and then by default, that nickel will be the 5 grams. So if you've got a matching list like that, you can sort of go through and say, what's the heaviest, what's the lightest? Let's work it through in that direction. All right, metric system has relationships between volume and weight. So a milliliter of water, it turns out, weighs a gram. All right, so now go by your factors of 1,000. That means a liter of water weighs a kilogram. So if you go back to my example over here, we had that 2-liter bottle of soda. That 2-liter bottle of soda we said weighed 2 kilograms, and it turns out that's exactly what it weighs. Because if a liter of water weighs a kilogram, you pick up that 2-liter bottle of soda, that 2-liter bottle of soda weighs 2 kilograms. So here's my question. I got a waterbed, measures 180 centimeters by 210 centimeters, and then is 20 centimeters tall. I'm going to fill that thing up with water. How many liters of water can it hold? Well, the first thing is, let's figure out how many cubic centimeters of water it can hold. 180 times 210 times 20 will give me an answer in cubic centimeters. It'll be a lot of cubic centimeters. Here, let's figure out what it is. 180 times 210 times 20, I get 756,000. 756,000 cubic centimeters. Well, maybe then a cubic centimeter isn't the best way to measure this. Maybe a liter would be a better way to do this. So cubic centimeters match up with milliliters. Right? So cubic centimeters match up with milliliters, so it means that there's 756,000 milliliters of water this thing can hold. Okay, how do I convert milliliters then to liters? Well, divide it by 1,000. And I end up with 756 liters of water that this thing can hold. Right, how much does that weigh? Well, back here we had said that a liter weighs a kilogram. So if 756 liters is what this bed holds, then its mass is 756 kilograms. Now, if you want a different measure, take that and divide it by 1,000, and is that many metric tons. That's a lot of water. Actually, that's a lot of weight. So you fill that water bed up with 756 liters of water, it weighs 3/4 of a metric ton. All right, what else can we measure? How about temperature? All right, in English units, we use Fahrenheit. In metric units, you use Celsius, or sometimes degrees centigrade. The two key points on here are the freezing point of water and the boiling point of water. In the Fahrenheit scale, you know 32 is freezing, 212 is boiling. In the Celsius scale, it goes between 0 and 100. So water freezes at 0 degrees centigrade. Water boils at 100 degrees centigrade. How do we convert, then, between one and the other? Well, look at the ratio that's left. If I take 212 and subtract 32, I end up with 180. So the ratio between Fahrenheit and centigrade is the ratio between 100 and 180. The formulas that we have look like this. We're going to take the Fahrenheit degrees, subtract 32, and multiply it by that ratio that we came up with, the 100 over the 180. Now, generally, we don't leave that as 100 over 180. We knock 20 out of the top and bottom, and we reduce it, or simplify it. Not reduce it, simplify it to 5/9. Okay. Works the other way, too. If you want to go from Celsius to Fahrenheit, you're going to multiply by, really, 9/5 and add 32. Question is, which direction do you want to go in? If you have degrees Fahrenheit, the degrees Celsius are going to be less. If you have degrees Celsius, there are going to be more degrees Fahrenheit. So to go from Fahrenheit to Celsius, you would multiply by a number that's bigger than 1. To go the other direction, you would multiply by something that's smaller than 1. All right, these are the simplified versions of these formulas. Multiply, take the Fahrenheit, subtract 32. That's in parentheses, so you do that first. And then multiply by 5/9, same thing the other way around. You don't have to memorize these formulas. I'll give them to you if you need them. Not every day you convert these things back and forth. All right, so the first question up here says, what kind of clothes would you wear outside if it's 22 degrees Celsius? I was somewhere where there were radio stations and television stations from across the border in Canada, and I was listening one night, and the temperature was given as, tomorrow will be 14 degrees. 14 degrees? And then I realized, no, it's 14 degrees Celsius. So if you don't know how to convert these two, you might not know what to wear if you go to a country that uses Celsius instead of Fahrenheit. So 22 degrees Celsius. What formula are we going to use? Well, we want Fahrenheit, because we know what kind of temperatures those are. Fahrenheit is 9/5 times the degrees Celsius, and then add 32. So our temperature in Fahrenheit is going to be 9/5. You can use 1.8 if you want. Times 22, and then add 32 degrees. So let's see what we get. If we take 9/5 times 22, then add 32, I get 71.6. All right, so you probably wouldn't need a winter jacket. I don't know if I guess that's kind of borderline for shorts, but certainly not a winter jacket. So the next question said find the high and low temperatures for today, so it depends what day you're watching this. If the low temperature, let's say, was 45. So let's say we knew that we had 45 degrees Fahrenheit. You want to convert that to Celsius. what's the formula for that? The number of degrees Celsius is going to be 5/9 the number of degrees Fahrenheit minus 32. So 5/9 times 45 minus 32. If I subtract those two, I get 13, and then multiply 13 by 5/9, and I get 7.22. So roughly 7 degrees centigrade. So if it was 45 degrees as an overnight low, it would be 7 degrees in terms of Celsius. And then if today's high was 71 or 72, then that would be the equivalent of 22 degrees Celsius. All right. If this helps, this is one of those old-fashioned mercury bulb thermometers. Don't drop it and break it. But it's got the Celsius scale on the right side. It's got the Fahrenheit scale on the left side. So you can see at 32 degrees Fahrenheit, then that's the equivalent of 0 degrees Celsius. Water boils. Cool day, 50 degrees outside. That's 10 degrees Celsius. Room temperature, they got a warm day, 77 Fahrenheit is 25 Celsius. A hot day might be 30 Celsius. Your normal body temperature is about 37 degrees centigrade, and water boils at 100. Right, and then obviously there's negatives for both of them. If you go below 32 degrees, then you're going to have negative degrees Celsius, and of course you can go below 0 in terms of Fahrenheit as well. All right, and that's the end of this section.